Well, hello, and how are you, my dear students? We are here in another lesson of our book, which is section 1.3 Indices. So, in the indices, now in the local book, it is the also we have got this section, but under the title of powers. And here, according to the Cambridge book, we study it with this title, which is indices. But I wish that we could study like section 2.3, 2.3 before this section because we need this kind of three rules here. Just show you. We need these three rules in that section. That's why I should define them here. I should mention them here in order to not face any problem. Okay, indices. Before diving deeply to the questions, I would love to mention them. So 1, 3 indices. Okay, perfect. So rule number 1 says if we have multiplication of powers or indices. I will mention this one. I already mentioned these indices, so it means powers. Powers with the same basis. All right. If we have if we have multiplication of powers with the same base, always keep the base, keep the base, and just wait a second. Keep the base and add the exponent. Example, let's say if we have 3 powered by 5 multiplied by 3 powered by 4, so keep the base, do not change the base, so keep these 3 and add these exponent 4 plus 5, 9. That is about multiplication of powers with the same base. Alright, we have variety of examples during the exercises. Don't worry, I'm pretty sure you are going to reach every single answer of the questions in your mind. Alright. Rule number 2 says if we have division with the same base, if we have division of powers, sorry, of I'm going to write here of powers with the same base, again keep the base, keep the base, keep the base, and subtract the exponent. So for division, we are going to again keep the base, we are not going to change the base, but subtract the exponent. Rule number 3 says if we have the term powered power by powered, power by power, again keep the base. We are not going to change the base. Be careful, guys. Never change the base. Always, in all the cases, keep the base. But in the third one, if you have power by power, again, keep the base. Then multiply the exponent. So for the subtraction, I forgot to give you an example. Imagine if you have like 6 powered by 3 divided by 6 powered by 2. In this case, for division, you know that we can just show it fractionally as well, like 6 powered by 3 over 6 powered by 2. So keep the base and subtract the exponent. 3 minus 2, 1. So you can write this one as 6 as well. That's power of 1. Doesn't make any change. Power by power. So if you have something like this, look, power times 6 powered by 5, all powered by another exponent. So let's say 5. So in this case, again, keep the base, but it says multiply the exponent. Multiply the exponent. So 5 times 5, 25. Right? So we have got some other notes, like rule number 4 says, it is just like a note, not a rule. So any number powered by powered by 0 equals to 1, except for 0 itself, because 0 powered by 0 is undefined. Example for these notes, let's say 100 powered by 0 is equal to 1. So 20, 201 powered by 0, again it's equal to 1. So number powered by 1 by 0 equals to 1 except for 0 itself. Notes number 5 says number powered by 1 equals to itself. Number powered by 1 equals to itself. That number itself. For example, like 20 powered by 1 is equal to 20 again. 35 powered by 1 it's equal to 35. So any number, even 1 powered by 1 is equal to 1. Okay? So number powered by 1 equals to itself. Rule number 6 says if we have, that is very important, like I would like to put a star on it. If we have our term with negative exponent, negative in this negative exponent, in order to turn it to positive exponent, we should flip it. In that case, it will become positive. What I mean by it, the exponent. So for example, imagine if we have something like 5 powered by negative 2. So we every single number in this world has like a denominator of 1. So if you flip this fraction, 1 is gonna come up, so it's gonna become 1 over 5 powered by, automatically this negative will become positive 2. Alright, so this is how we turn a negative exponent to a positive exponent. I'm sorry. Let's say if we have this example, 2 over like 7, all powered by negative 3. So it's going to become, first we need to flip this base, so it will become 7 over 2, all powered by 3. Or let's say if we have if we have something like 14 over 2 all powered by negative 3. So it's going to become, first try to do this division. So 14 divided by 2, 7, sorry, 7 powered by negative 3. So you know that this one has a denominator of 1. If you flip it, it's going to become 1 over 7 to the power of 3. That is how we turn a negative exponent to positive exponent, by just what? By just flipping the base. All right. So that's all about the explanation of this section. I hope that you write it down, so you can just pause the video and write the explanation. So let's just keep this one here, and let's move to the questions deeply. I hope that the screen is clear for you, guys. The first question, I'm not going to solve all the questions in order to not make the video long, because the other two sections, they were a little bit like long. That's why I'm afraid that you don't have power to watch all the video. That's why let's just solve some questions that I'm pretty sure like it's going to make the topic understandable. Write each number as a fraction. All right. So as you can see, whenever we have a negative exponent, we should flip the number. All right. In each of these cases, there is a denominator of 1. All right. So if you flip, for example, this one, it's going to become 1 over 4 to the power of 1, which is 1 over 4. All right. This one is going to become, look, don't forget about the denominator of 1, so it's going to become 1 over 2 to the power of 3. Automatically, this negative 3 is going to become positive 3. So you can write 1 over 8. This one has a denominator of 1, so it's going to become 1 over 9 to the power of 2, which is 1 over 81. The next one, I will leave these 3 for you. I mean, these two, okay, D and E for you, and F, I will do it too. So it's going to become 1 over 2 to the power of positive of, which is 1 over 32. Now here is very nice question. Here are 5 numbers. Order them. So from smallest first, okay? So list the numbers in order of size, smallest first. First of all, we need to turn this power term with negative exponent to positive exponent. All right. So the first one, 2 to the power of negative 4, it's going to become 1 over 2 to the power of 4, which is 1 over 16. Okay. Then 3 to the power of negative 3, it's going to become 1 over 3 to the power of 3, which is 1 over 27. Then the next one is 1 over 4 to the power of negative 2. When it is come down, it comes down, so it's gonna become 4 to the power of 2, which is 1 over 16. And then 5 to the power of negative 1, so it's gonna become 1 over 5 to the power of 1, which is 1 over 5. And then this one is the most tricky one, 6 powered by 0. We said any number powered by 0. Look, according to the note 4, any number powered by 0 equals to 1. So 6 powers by 0, it's equal to 1. Now, if you want to order them, these are all fractions, the first 4. But the last one, it's 1. So it's going to become the bigger one. Right? Then, to since the numerators are equal, in order to compare these fractions, we have to say like this: a fraction is bigger that it has a smaller denominator. All right. So for example, right now, the fraction with smaller denominator is 1 over 5. So 1 over 5 is the next bigger one. Then 1 over 16 is equal to 1 over 16. So we may write it down like this. And then the last one is 1 over 27. It's because since it has the biggest denominator, so it's going to become the smaller number. Imagine if you have a pizza and divide it by 27 pieces. So picking up only one piece of it it's going to be smaller than if we divide this pizza, the same pizza, by like into 5 pieces, uh, picking up only one slice of it. So of course that amount of the pizza is going to be bigger than this amount. I hope that's clear to you guys. Now we have this type of question. It says write this number as a power of 2. Whenever it says write a number as a power of like something, that's number will become the base. For example here, so 1 over 2. 1 over 2, you know that uh, we have to write it down as a power of 2. So it means base must be 2. How we can write it down? If you bring up these 2, so it's going to become 2 to the power of negative 1. As you can see, we wrote 1 over 2 as a power of 2. We bring up this 2, we flipped it, so whenever you flip the exponent, well, the sign of the exponent will change automatically. What about this 1 over 4? Everybody know that it's equal to 1 over 2 to the power of 2. Now again, if you flip it, so it's going to become 2 to the power of negative 2. And as you can see, we wrote 1 over 4 as a power of 2. What about 64? I'm pretty sure it might be the easiest one. So 64, if you go and search it, we can write it down as a power of 2 to the power of 6, which means if you multiply 2 6 times by itself, you're gonna get 64. Therefore, 1 over 64, it's going to be 2 to the power of negative 6. 64 is in the denominator. What about 1? This one is the most tricky part in this question. Like 2 to the power of what equals to 1? There is only one option, which is 0. So we wrote 1 as a power of 2. And then what about 8 to the power of negative 1? Remember powered by power term. So the purpose is we need to make something like that. 8. Okay, ignore this negative 1 first. What is 8 in terms of power of 2? So it is 2 to the power of 3. Then we have got a negative 1 already. So remember powered by power term. We said that keep the base and multiply the exponent. 3 times negative 1, negative 3. So write each number as a power of 10. I'm going to solve 2 of them, then I will leave the others for you. So 1000 as a power of 10, it is equal to 10 to the power of 3. Like if you multiply 10 3 times by itself, you are going to get 1000. That's why 1000 as a power of 3, as a power of 10 equals to 10 to the power of 3. What about this number? Remember, it is a number between 0 and 1. Remember, second section we discussed about this. So the power of 10 is going to be definitely negative. So if you move the decimal number 1, 2, 3, 4, 5, so it's going to become 1 multiplied by 10 to the power of negative 5. So we can write it basically in this way as well. 10 to the power of negative 5. Oh, sorry. 1, 2, 3, 4, 5, 6. So it's going to become 6. Which is 1 over 1 million. Yes. It's going to become 6. So I will leave the others for you in question 4. What about question 5? It says write 1 over 64 as in part A as a power of 64. So if we flip it, so it will become 64 to the power of negative 1, and we wrote it as a power of 64. What if we write it down as a power of 8? So 1 over 64, it is basically equal to 1 over 8 to the power of 2. If we flip it, guys, don't forget, You might say, is this one can be the answer? No, because this one is the fraction form, and we have to write it down as a power of 8. So 8, if you flip it, it's going to become 8 to the power of negative 2. So I will leave the other two for you. Write 1 over 81 as a power of a positive integer. So we can write as a power of positive integer. 1 over 81 can be written as 81 to the power of negative 1, or 9 to the power of negative 2, or 3 to the power of negative 4. Go and check it. You are going to get these three results, because 1 over 81, 1 over 1 over 81 equal to 1 over 9 to the power of 2, and 1 over 3 to the power of 4. So if you flip these three, we are going to get these three results. So we wrote 1 over 81 as a power of a positive integer. Okay, you might ask me, teacher, the exponent is negative, so we don't care about the exponent. The base must be positive integer, and 81 is positive, 9 is positive, 3 is positive. Here, question 7. When x equal to 6, find the value of these four numbers. So instead of x, write 6. I will solve b and c, then I will leave the others for you. B is, so instead of x, if you put 6 to the power of negative 2, so it's going to become 1 over 6 to the power of 2 if you flip it, which is 1 over 36, right? And here 6 powered by 0, everybody know that it's equal to 1. So I will leave these two for you. Write m to the power of negative 2 as a fraction when m equals to 9. So instead of this m, write 9 to the power of negative 2. It says as a fraction, so we have to flip it. 1 over 9 to the power of 2, which is 1 over 81. And part D, instead of mf, we have 20, so substitute 20 to the power of negative 2, because in the title it says m to the power of negative 2. Then part D said, what if m equals to 20? So 20 to the power of negative 2 is equal to 1 over 20 to the power of 2, which is 1 over 400. Write y as a mixed number when okay, y is here, y equal to x squared plus x to the power of negative 2, and x is a positive number. So if we have, I will just solve one of them. If you have, instead of x3, so y is going to be 3 squared plus 3 to the power of negative 2. So 3 squared is equal to 9, plus 3 to the power of negative 2. If you flip it, it's going to give us 1 over 9. So 9 plus 1 over 9, it is equal to, make a common denominator. Already 9 is a common denominator. So 9 divided by 1, 9 times 9, 81. 81 plus 1, 82 over 9. Or write y as a mixed number, so we can write 9, 1 over 9. 1 is correct. In part B says, find the value of x when y equal to this and y equal to this. I will solve one of these two, then I will leave the other one for you. So I will solve I, which is the first part. So instead of y, remember y is here. So instead of y, we have this number, 25.04 equals to x to the power of 2 plus x to the power of negative 2. So we have to find a base. Let's say if you find 5, if we say x equal to 5, try and test it. So 5 squared plus 5 to the power of negative 2. Will it give us this number? Let's see. 5 squared is equal to 25, plus 5 to the power of negative 2 it is equal to 1 over 25. Alright? So if you multiply this one by 4, this fraction, we are going to get 25 plus 4 over 100, which is exactly this number, 25.04. So it means x must be 5. So go and find x for this number. It is easy. Right now, these are the questions that we can follow the rules that we study on them for them. So here I will just solve two of them. Write the answer to each multiplication as a power of 3. So we have multiplication of powers with the same base. All right. So keep the base. For example, part 3, keep the base and add these exponents. So 4 plus 6, 10. And here, so what about the last part? Whenever there is no exponent, so the exponent is 1, don't forget this. 3 powered by 1 times 3 times 3 powered by 5. So keep the base, don't change the base, but for multiplication, add the exponent. So 5 plus 1, 6. I will leave the first and the second for you guys. And here is the rule is written, by the way. Then in this question, as you can see, we are dealing with negative number. So here, let me just tell you something else. Let me remind you something really important, because students always have problem with this part. Like negative multiplied by negative, positive multiplied by positive, and negative times positive, positive times negative. For multiplication, we have got these 4 rules. So if the signs are the same, then multiplication is going to be positive. Negative times negative, positive. Positive times positive, positive. But if the signs are different, the multiplication of them will give us negative sign. These rules works for division as well. That is for the multiplication. Okay, multiplication. What about if you add integers? What will happen? So in addition, the story is different. How? Like positive plus positive, so the result is obviously positive. Negative plus negative, the result is always negative. Don't forget this. When we add negative number to another negative number, the result is always negative. But there is only one case of the different signs. When we add different signs, first subtract them from each other. Then keep the sign of the bigger one in the result. Don't forget this one. For example, let's just mention one example here. 6 plus negative 9. So we said first subtract them from each other. So 9 minus 6, 3. Keep the sign of the bigger number. What is the sign? 9 and 6. 9 is bigger, obviously. So the sign of 9 is negative. So the result must be negative. That much simple. Okay. You might just want to note down this one. So you may just add it to the explanation part of this section. Perfect. Now I will solve 2 of them. Then I will move to another example. 3 to the power of 3 times 3 to the power of negative 1. So keep base 3 plus negative 1. So 3 plus negative 1. The signs are different, so subtract them. 3 minus 1, 2. Take the sign of the bigger one. The sign of 3 is positive, so it should be positive. Alright. And here, So keep the base 3 and negative 2 plus negative 1. Remember, in multiplication we add the exponent. So addition of two negative numbers, we said always add them. Look, let me just add this to add them, but the result is always negative. That's why here I said the result is negative. But first add them. So 2 plus 1, 3, but with negative. So 3 to the power of negative 3, and we should flip it. That is all about this question. The others are going to be easy, I'm pretty sure. We have got something else here. So I will do B and C, then I will leave A and D for you. Or B and D. I will do B and D. So keep 5 at the exponent 4 plus negative 2. So 4 plus negative 2, since the signs are different, subtract them. 4 minus 2, 2. Keep the sign of the bigger one, which is positive 2. So 5 to the power of 2. And here D, keep the base 5 and add the exponent. So negative 4 plus negative 2. Put them inside the bracket in order to not confuse. So for the addition of two negative numbers, first add them. No problem. 4 plus 2, 6, but with negative. Negative 6. So if you flip it, it's going to become 1 over 5 to the power of 6. Always try to write the final solution as a positive exponent. So I will leave multiplication, or it's better to just solve one question here, since it's just like an equation. We'll talk about equation in chapter 4, I guess. So if you bring down this question, it is a multiplication of powers with the same base, but one exponent is missing, so we have to find it out. 12, keep the base here, negative 3 plus x equals to 12 to the power of 2. So since since we are dealing with an equation, left and right side must be equal to each other. So bases are equal, exponent must be equal to each other. Negative 3 plus x equals to 2. We said that already. I'm going to mention it again in the equation part. Variable must stay in one side as a positive term, and number must go to the other side. So here our variable is positive, so it has no problem. We should move this negative 3 to the other side. Whenever we move a term from one side to another side, the sign will change automatically. Means x equals to 2. Here is negative 3. When it comes to here, it will become positive. So plus 3. Therefore, x equal to 5. Do the others just like this. For division, guys, so keep the base, keep the 10, and subtract the exponent. So 3 minus 8. So one of them is positive, the other one is negative. Subtract them. 8 minus 3, 5. Keep the sign of the bigger one. 10 to the power of negative 5, which is 1 over 10 to the power of 5. Okay, others are going to be a piece of cake for you. Let's do D here. Bases are equal, are the same, so keep this base, don't change it. Negative 3 minus, careful about this one, it's a little bit tricky, minus negative 5. So 12 to the power of. First, we need to make one sign here. So negative times negative, look, negative times negative, positive. So negative 3 plus 5. Now 12 to the power of, finally. Signs are different. Subtract them. 5 minus 3, 2. Choose the sign of the bigger one, which is positive. So positive 2. I'm sorry. Let's do one more question here. Okay, keep the base, don't change it. Negative 4 minus 2. All right, there are two negative numbers. We keep the base, don't change it. The addition of two negative number, here we said add them. Okay, 4 plus 2, 6. But the result is always negative when we add two negative numbers. Finally, we are in question 17. I will solve one of them. Others are going to be your responsibility. According to this sign, student must do this one by themselves. Okay, let me just choose the hardest one, which is F. It says write down 27 to the power of negative 2 as a power of 9. We said whenever the question asks us to write a power term as a power of a number, that number will become our base. So it means 9 is the base. So 27 as a power of negative 2. As a power of, 27 to the power of negative 2 as a power of 9. So first of all, I would like you to tell me what is 27. So we can write it down as 3 to the power of 3 to the power of negative 2. You must remember the commutative property from the previous grades. If we change the place of these two, it's not going to make any problem, right? So let's say 3 to the power of negative 2. I'm going to change the places. All powered by 3. All right? Even if we just put this negative outside, so still it's the same. 3 to the power of 2, all powered by negative 3. All right, so 3 to the power of 2, 9. 9 to the power of negative 3. And we wrote 27 to the power of negative 2 as a power of 9. All right. So here is the end of this section. I hope that I gave you the message of this section. Try to solve these questions by yourself, because most of the teachers focused on this page, on that idea of these questions. And if you want to test yourself whether you got benefit and you got these three topics, please try to answer these questions by yourself. Thank you so much for listening to me up to now, and have a nice day. See you in another video.